Hello, 8th graders. It's Mr. Cavey back with part 2 of a sort of an introduction and an orientation to this learning target, which says I can visualize, describe, and identify situations where percents are less than 1% or greater than 100%. So yesterday, or in my last video, I sort of went through the introduction to the chapter and just barely got into 8.1 in your MathLinks textbook. And so I'd like to get a little bit deeper today and keep going with this. And I think in order to do that, I'm going to go back to DocHub. So let me do that. All right, so this is kind of where we left off at 8.1, understanding large and small percents. And over here you can see basically the learning target that I am focusing on for this particular lesson. So we talked yesterday about population. We started to get into these examples, and I'd like to continue that a little further and then hopefully get into the questions that I assigned to my 8th graders for this assignment. Number 2 says, ask your teacher or research to find an approximate number for each of the following populations, then work with a partner to determine the approximate percent that one person represents compared with all the people in A, your town, city, or area. So let's start there. A, your town, city, or area. What percent would that represent? Well, that's actually not as easy as you might think, because we're talking about a percent. We know it'll be less than 1%, because 1% would be 1 in 100. You are going to be 1 in, insert the population of your city. So there are different ways to experiment with that. Let's try the city of Vancouver, since that is where we all go to school. And, you know, if you need any of these population figures, actually, it doesn't hurt to Google them. So let's see what the population of Vancouver looks like. It is 675,000. By the way, I live in a city called Surrey. Let's see what that population is. 518,000. All right, so it's catching up. Oh, I like how they sort of compare the neighbors. So if you live in Burnaby, it's 249,000. Surrey, 518. Yeah, Vancouver, 675. Okay, interesting. All right, well, we will use Vancouver, which is 675,000. So let's go back here. All right, so on your calculator, what you're going to do is 1 divided by, this is going to be a very small number. It's okay to round, so 675,000 people equals, oh, great. Oh, my goodness. Okay. So to help us with this, basically what we're going to do, okay, I've got to show you a couple of things. Can I copy and paste this number? Doesn't look like I can. Okay. Difficult. See, it's always so good for me to see the problems that I'm assigning. Wait, come back. Won't the calculator stay there? Maybe not. Oh, okay. Even more difficult. You don't have this option, but I'm actually going to take a picture of this so I can remember the number. Okay, I've got the picture on my phone. And so here, I'm going to show you the number, and then we'll talk about what percent that represents. I want to write in red. Okay. So the number is 0.0, get this right, 0.0000. 1, 2, 3, 4, 5. 3, 4, 5. 1, 4, 8. 1, 4, 8. And it's actually repeating. So we can write that. We can draw the bar over. We talked about that yesterday. Now, what about a percent? So I'm going to put equals. What is the percent? Well, when we look at numbers with decimals and we convert to percentage, it's so important to remember, and I'll probably repeat this many times, it's the first 2 place values, the first 2 digits that represent the value over 100. So basically, to find a percent, you're moving the decimal over 2 spaces. And then whatever is on the left of that new decimal position, that is going to be the percent. So in this case, we only have 0 on the left. So going to put 0 and then 0.00148%. And that is a very small number. Now, in the when we get to the profits, it's going to be even smaller. I had to read that again to make sure I'm doing this right. These are very small percentages. Okay, so let's find the population of British Columbia. I think that's going to be, for it shows, I predict, 5.1 million. Yes! Okay. 5.1 million. So, again, show you the calculator portion. 1, that's you, divided by 5. 1, 0, 0, 0, 0, 0. Trying hard not to make any mistakes. Ugh. Okay. Really large. Another really large number. It does say to find an approximate number. Oh, the approximate percent. I mean, so I'm reading the instruction again, and maybe approximate percent, yeah. Well, let's solve one more, and then when it comes to Canada and the world, I think we're just going to round down to 0%. You're certainly closer to 0 than 1%. A lot closer. But we'll follow this through with the province. So, okay. Again, I'm going to do just as I did above. I'm going to write out the full number. Okay. So we've got 0.0000006 zeros. 196,078,431. What a bizarre number. Okay, and then unfortunately, it's getting a little bit messier than I would like, but that is going to equal. So remember, we're basically just moving this decimal place over 2 spots, and that's going to be the percent. So 0.0. I'm getting old. Wait. 1, 2, 3, 4, 5, 6. So it should be. Yeah, that makes sense. 4 zeros and 196. I'm just going to round it. There. Okay. So that is the percent that you represent in British Columbia. Now, when it comes to Canada, of course, the population of British Columbia was 5+ million. When it comes to population of Canada, we've got a much larger number, 38 million. So now you start to think, like, what percent am I out of 38 million? That's going to be even more zeros to the left of any other numbers. So like I said, it's going to be, I think what I'm going to do for C, and I'm not looking at the answer key, so I'm curious to see what it would say, but frankly, it's just 0%. For D, the world, oh, definitely 0%. Because now when we're talking the world, it's 1 out of, 7.6 billion. I wrote 7 billion up here just because that's what, oh, it's well over, yeah. So 7.6 billion. In number 1 and 2, were any percents less than 1%? Yes. Okay, so which ones? So one C. Oops. Okay, capital C. 1C, 2A, 2B, 2C, 2D. Okay. And were any of them fractional percents? So again, the definition of a fractional percent is a percent that is not a whole number, but instead includes a fractional or decimal portion of a percent. For example, 4.5%, 7 3/8%, 125.2%, 0.5%, 0.42%. Unless I'm missing something, all of the same were fractional percents because they're less than a whole in this case. And keep in mind, it can be greater than one whole and still be a fractional percent. If it includes, and in the case of 4.5, if it includes any part of a whole number, it is a fractional percent. So I'm going to say all the same. Or maybe I should just copy and paste. Okay. All right. Just want to do a refresher on the questions that I assigned here. Okay, so 1 to 15, all right? So we continue. Part B. How full can you make it? Determine the maximum volume capacity of a measuring container. So I think we will put a pause on that question, did a little thinking about that, and these questions would be fun if we all had easy access to measuring equipment and maybe an industrial kitchen. But for now, we're going to skip down, I think, to the assignment. Maybe we'll, just before that, let's make a couple of quick stops here at Develop Understanding. So looking at example 1, represent percents visually using 100 grids. So in class yesterday when I introduced this lesson, some people pushed back pretty hard on this idea of actually coloring in grids and sort of complained about how long it takes. But I think this is really helpful for us to visualize it. So without reading all of this text here, it's important to note that 135% can be visualized by, where are my writing tools in DocHub? Okay, so as I was saying, it's really important to be able to visualize 135% as basically two squares. The first one completely shaded in. The second one, 35 cells out of 100 shaded in. And this may seem obvious to you, but we're going to come back to these grids often because sometimes there can be confusion between 1% or 0.1%, and those grids are going to be really helpful. So yes, here we have an example of what I'm talking about. If you pause, it might be helpful to zoom in on the screen, but 0.7% is not the same as 7%, right? Can I increase my little marker here? If I color in, oh, that's perfect. 4, 5, 6, 7. If I color in 7 cells, that equals 7%. Now I want the small marker again. 7%. But that is different than 0.7%, right? 0.7% is just a piece of 1%. So that's why we're going to zoom out and create this little square here, which represents, this cell. We're going to divide it into 10 parts and then shade it, shade 7 portions of this 10-part square. 7 out of 10 is going to represent a fractional percent, 0.7%. So this is 0.7%. And, something to think about is, can I separate in my mind 70%, which would be, again, 70 of these cells shaded in, 7%, which is just 7 cells, and 0.7%. Okay, More examples. 18 3/4%. So again, we have a fractional percent. We're going to color in 18 or shade 18 holes. And then this 19th cell, we're going to zoom out and say we're only going to shade in 3/4 of that 19th cell because of this 3/4%. So you know, so what percent does each diagram represent? Well, this first one would be 120%. The second one would be, now keep in mind this is less than 1%. It's not going to be 1. It's going to be half. Whoops, I did that wrong. Let's do Command C. 0.5%. Let's see if my 5 comes back. No, it's gone. Oh. Okay. Doc Hub, you drive me crazy, Doc Hub. And that can be the same, that can be understood as 0.5%. All right. Keep in mind, 0.5% is very different than 50%. That is, when we see that percent sign, we understand it differently. Aaron sees these two cereal boxes on a shelf. The new bigger box is what percent of the original one? Okay, this is a great question. How do we find that out? Well, sometimes it can be confusing, or it can be hard to remember which number we divide by which number. But it's important you can always sort of double check by estimating. So in this case, we know the bigger box has to be 1 point something. What percent of the original one? It's a bigger percentage. Oh, and we don't even need to do measuring because they tell us right here. So there's an extra 25%. So in a way, that's unfortunate. But this is 125%. Because what you're doing is you're saying this is a whole. This is 100%. Oh, there we go. That's a whole. This one, we're adding 25% of this box. So this is essentially 125%. Just to make this really clear. Right? Aaron suspects that the company has not accurately represented the size of the bonus amount on the outside of the new bigger box based on the size of the boxes. Is she correct? Well, we can do the math here. I don't know if that's what this is asking. The number of grams is not really the size of the boxes. It's a measurement of the mass inside. This box actually looks a bit narrower. Interesting. But anyway, if we divide 500 by 400, we find 1. Excuse my messy writing. Decimal there. Bring the 0 down. Two times 400 is 800. You can see where this is going, right? 200. And then we'll bring down another 0. 2000. The answer is correct, 1.25. So this equals this, right? 1.25 and 125% are the same thing. Okay, let's move down because we haven't even started our assignment yet. Let me just see if there's anything we need to understand here. This is an interesting estimation problem that might be helpful. Estimate which provinces and territories each make up less than 1% of Canada in both population and land area. Okay. I like this because there's, like I say, I mean, estimation is great. It's an important skill, and it demonstrates a deeper understanding. So let's see how well we can do at this. Keep in mind, 1% is the same as 100th part. 100th. Now, so they say by land area, sorry, population and land area. So population is 35 million. What is 1% of 35 million? We can find that basically if we're going to type it into our calculator. We would type this. Now, before I show you the answer, I just want to show you a trick as well. 800. Is that 8 going to show up? Yeah. 38,851,800. So you can do two things. You can divide by 100. So you can go like this. Oh, you can write outside the page. That's cool. Or you can accomplish the same thing by multiplying by 100th. You're doing the same thing. So when you do that, all you're doing, you've got 0.01, all you're doing is you're moving the decimal 2 spots. Nope, pardon me. Thanks. That was a boo-boo. 2 spots to the left. There we go. That is 1%. So you've got 358. 518. 358,000. That is 1%. So let's take a look at population. They're asking how many provinces and territories make up less than 1%. Prince Edward Island, right? Population is less than 358,000. And no surprise, the territories. They're tiny in terms of population. For land area, we're going by this number, 9 million. So 1% of 9 million is going to be 90,000. And again, I can see that right away by just moving the decimal. Why do I keep doing that? 2 spots to the left. Maybe I should show you that. 9093 507. Times, just like up here, 0.01. And that's going to mean we're going to multiply, or pardon me, move the decimal 2 spots to the left, which is going to give us 90,000. Now, again, I want to show you what I'm doing, and I'm sort of taking this slow, but as you do more of these problems, you'll be able to look at a number and instantly say, okay, 1% of that number, I'm moving the decimal 2 spots to the left, and it becomes an easy estimation tool. So we see PEI, no surprise again. PEI is very small island. Nova Scotia, a little bigger, but still less than 1%. New Brunswick, less than 1%. All the other provinces are pretty big, and the territories are quite huge, as it turns out. So, we answered A. Of the 10 provinces, PEI is the smallest by land area and by population. BC is one of the largest. Use a calculator to determine the approximate percent of Canada's population and land area that each one represents. So, just in terms of estimation, it says determine, it says the approximate percent. Okay, so just for the sake of time, maybe I will estimate these. So what I would do is divide 146. I can show you my operations here for the population of Prince Edward Island. 146,400 divided by total population. I want to make sure I'm doing this in the right order. 35,851, 800. So that would be 4%. That's not right. What am I doing wrong here? Doing something wrong. Did I type in the wrong population for Canada? Let's try that again. 400 divided by 35,851, 800. Okay, so I was on the right track, just making a little bit of a mental boo-boo. So, of course, we've got that when the first two digits in our response are 0 and 0, we know it's going to be 0.something percent. So, it's not 4%, it's going to be 0.4%. So, that's my answer here for PEI in terms of population as a part of Canada. Maybe I will... they don't really give us a good place to write this. So basically that would look like PEI, population, 0.4%. BC will be interesting to see how it compares. And land area, I'll just write area. Now let's go back and make this a little neater. Whoops. Land area of Canada. So, wow, this is going to be small. 5,660. 5,660 divided by 9,093,507. 2 zeros, so it's going to be 0.06%. It's weird that it does that. Okay, BC, same thing. Population of Canada. Now, before I operate my calculator here, British Columbia has a population of, well, you and I know now, 5.1 million, so this textbook is a few years old, but here it has a population of about 4.7 million, and total population of the country is 35 million, as we see here. We actually know it's a little higher, but this, oops, can't. BC, okay. All right, so just by way of an estimate, I would say about approximately 5 out of 35 is 1/7, And so we're looking at something like maybe 15%, something in that range. So let's see how close my estimate is. We'll type in British Columbia 4683100 divided by 35,851,800. Oh, 13%. Okay. I was 1% off. 13, and then we can round this 06 to 1. So we'll say 13.1%. My favorite number. Very nice, BC. And then land area of Canada. $925 out of 9 million. Ah, interesting. So because it's close to 900,000 and the total land area of the country is 9 million, again rounding, this is going to be very close to 10%. Watch this. So we've got 925,186 divided by 9,093,507. 10 point, we can round this 17 up to a 2, so 10.2%. Very close. Good estimate, Mr. Cavey. All right, now that was a good practice, some good problems there. Now, I want us to take a look at today's assignment. So, represent each percent on a grid. If you have a notebook, math notebook with grid paper, you're going to be drawing a few grids. Now, for my in-class students, I said that you could, you know what, maybe I will stop here and start a new video, since this one's already gone quite long, and I'll start a new video for today's assignment.